Let's look at book 2, proposition 10 of Euclid's Elements. It is very similar to the previous proposition, where we had divided this segment into two equal parts and two unequal parts, right? Now here the difference is that we will divide it by into two equal parts, but instead of having the fourth point somewhere in between AB, we are going to take it beyond. Okay, so let's see. We know how to bisect a line. Okay, so we have got point C as the midpoint. Now we take a point beyond B. So let's make a circle at B of some random radius, and let's extend this line, get the point of intersection. So now AB has been extended to D. This could be anywhere. It doesn't matter where it. Now let's join BD. What the proposition says is that AD square plus BD square is equal to 2 times AC square plus CD square. So the proposition remains the same. The only thing is D is beyond K. So just like previous proposition, let's draw a perpendicular at C equal to BC or AC. Since they are both equal, it doesn't really matter. We had already drawn this line segment to get the point C. Keeping C as the center, let's draw a circle and the point of intersection. We are only interested in one of these. And now we make this line segment disappear and we join all these points. EA, EB, CE. We have to draw a line parallel to AB at A. So let's do that and join EF. So these two lines are parallel. Now we have to draw a line FD parallel to EC. We can directly connect these two because we have used the appropriate radiuses for those circles. So we join these two. Now the thing is, these two are parallel lines and this is going to be perpendicular to this. Why? Because this is perpendicular. CE is perpendicular to AD. So in a parallelogram, opposite side angles are equal. So that means this is also 90 degree. These two lines are parallel. So which means this angle is also 90 degree and this angle FEB or BEF is going to be less than this angle 90 degree. Since it is less than 90 degree, that means this line segment is going to meet the line segment FD if they are extended. So let's extend them. So let's say they meet at G. So let's hide these and join these points. And let's join AG as well. Okay, now the construction part is over. Now we have to prove that AD square plus BD square is equal to 2 times AC square plus CD square. What all do we have? We have angle BCE, which is perpendicular, because that is how we constructed it. That means angle ACE is also 90 degree. We know AC is equal to CE. These two angles have to be equal. Why? Because angles opposite to equal sides. So which means angle AEC is equal to CAE. And they are going to be 45 degrees. That is half right angles. Let's get these angles all in place. Now, same case In this triangle BCE, angle CEB is equal to EBC. Again, they are going to be 45 degree because they are equal and this is 90 degree. The sum has to be 180 degree. So these will be 45 degree. Now this is 45 degree. This is 45 degree. That means angle AEB is equal to 90 degree. So I can hide these two. So this is 90 degree now. Okay. What else can we infer? We know angle EFD is also 90 degree. What else do we know? We know BDG is also going to be 90 degree. These two lines are parallel and these two are corresponding angles. What else? We know angle GBD is equal to 45 degree. Why? Because EBC is 45 degree. And these two are vertically opposite angles. This is 90 degree. This is 45 degree. That means this has to be 45 degree. If these two angles are equal, that means BD equal to DG. Now what else? Look at EF and AD. They are both parallel lines. And EB is the traversal. That means angle BEF is equal to GBD, which means FEG is equal to FGE. Why? Because this angle is equal to this angle is equal to this angle. So that means these two angles are equal. Now let's look at these triangles. AEC. AE square is equal to AC square plus CE square, Pythagoras theorem, or rather proposition 47 of book 1. And these two, AC is equal to EC. So we can say AE square is equal to 2 times AC square. Okay, now let's look at this triangle EGF. This is 90 degree. These two angles are equal. Since these two lines are equal, EF is equal to FG. So we can say EG square is equal to 2 times EF square, because these two sides are equal. But EF is equal to CD. So we can say EG square is equal to 2 times CD square. Now let's look at AEG. AE square plus EG square equal to AG square. But AE square is 2 times AC square and EG square is equal to 2 times CD square. So here we have AG square is equal to AE square plus EG square, because this is right angle. So we can apply proposition 47. AG square is equal to AE square plus EG square. But AE square is equal to 2 times AC square. EG square is 2 times CD square. So AG square is equal to 2 times the sum of AC square and CD square. But remember, AG square is also equal to AD square plus DG square. So we can say AD square plus DG square is equal to 2 times AC square plus CD square. But DG is equal to BD, sides opposite to equal angles. So instead of saying DG square, we can say BD square. So we have ended up with AD square plus BD square is equal to 2 times the sum of AC square and CD square. So that is proposition 10. Too many things to focus on, based on my talk, but you can refer to the book, a PDF book, where I describe all these propositions, and there all this proof is there step by step. You can refer to it. That's it for now.